starting with Rafał's presentation, contrary to some I think was very practical compared to mine, because I will be talking about some history and concepts, and I will try to show you that right now we are in an era of non-perfect solutions, non-perfect IT solutions. These solutions stand in opposition to traditional IT, and thanks to that new approach, IT is capable of doing much more than it was possible in past. Okay. Let's start with some history. I said that imperfect solutions are quite new stuff. I mean, like 10 years, but actually it started way earlier. But the reasons were different. In the initial era, IT didn't have enough processing power to do anything more than imperfect. So, for example, in Apollo program, they used guidance computer. That was first guidance computer this small. It doesn't fit into a building. It was fitting into something of a size of a suitcase. But there was a problem because during regular procedures like landing or changing orbit, it was consuming 90% of the computing power available. The guidance program was consuming almost all resources, and there was no option to improve the hardware because it was everything they could get. So they somehow had to solve this and work with imperfect solution that they had. So they had several options. They could hope for the best, but if something breaks, then people would die. So they didn't consider it a viable option. They could scale up, but they couldn't fit more into what space and, more importantly, what power they had available in the lander. They could wait for a better computer. Moore's law was already discovered at that time, so they could wait for 2 years and get a better guidance computer. But then probably Russians would be first on the moon, so that wasn't an option as well. They could use dedicated hardware, signal computer that was just for single purpose. But instead they preferred to use general purpose computer that could be used in different places. The guidance computer, the same unit was used in lander, in lunar lander, and also in orbital unit. The same computer, just different software. So that was the design decision they had. So what they could do? They did something called R1202. Whenever a computer was identifying a situation where the queue of upcoming events to process is overloading, it simply initiated a soft reboot procedure without dropping the navigation data. It was dropping all the events and starting from zero. It was taking several seconds, and pretty much no one knew about it because that was little engineering secret. But this decision saved lives. During lunar landing of Apollo 11, computer was overloaded when someone switched on additional radar. Computer was overloaded with data and started rebooting itself instead of just crashing. And after several reboots, they reached the designated area and they just landed, thanks to this approach that computer can kill itself. It also saved lives in yet another situation. I told you that there was a decision to use the same general purpose computer in both lander and orbiter during Apollo 13, because orbiter was severely damaged. Astronauts need to fly back to Earth in lunar lander, and the navigation program was flashed from Earth to the lander. They changed the program in flight and enabled the navigation to the Earth. So general purpose navigation computer saved lives here as well. Okay, let's switch and talk something more down to earth. The SQL transactional database is using very nice paradigm. Is using ACID transactions. It's very powerful. It guarantees that whenever happens within the transaction is permanent, happens only within the transaction, and you have a guarantee that nothing interacts with what's happening with the transaction. And this kind of databases was used for decades. They had only one problem. They did not scale. If you wanted to have a better database, you just had to buy new computer, new hardware. You cannot join two separate computers, join their processing power. You had to buy one single processing unit, and it was expensive. So, after some years, what happened? NoSQL database happened. The NoSQL database are very better than SQL database? What do you think?
Different.
Very different, right? But the concept behind them is, let's call it, more dirty. It's more down to earth. We realized that you cannot have it all. So we need to design of some things, right? You cannot have full ACID transaction support and scalability. So in that way, NoSQL database is far less perfect. Most of them don't support full-scale transactions, but they give something in exchange. There isn't one solution fits all. There are many different solutions. You can choose what do you need. You have the choice, but you need to make the choice, and you need to be aware what kind of choice you are making. Instead of just choosing one size fits all perfect model with SQL transaction, you need to make some compromise to make your solution. Another example, Kafka. Okay.
Because we can see it.
Okay, so Kafka is was, because right now it's kind of standard, but when it showed up, it was star new technology, something from different storyline. If you can check the bandwidth that can be achieved with different MQ technologies, Kafka is completely different league, right? And everyone loved Kafka since the day one. Yeah. In enterprise architects world, it was very complicated love, because we loved Kafka since the day one, but we are not allowed to use it. So we can just watch how startup companies do wonders with Kafka. But what's the source of the power of Kafka? Well, it's different paradigm. It's like with SQL and NoSQL databases. NoSQL database uses different model for storing data, different concept. And the same with Kafka. Traditional MQs are using exactly once delivery model. This is very nice concept. MQ is guaranteeing that your message will be delivered to subscriber exactly once. It will not be duplicated, and he will get it for sure. Kafka doesn't do such stuff. The best it can do is at least once. So instead of tracking what message was delivered when, where, and when, it just gives you ability to read all the messages that are there and make you decide if the message you received is valid for you or not. So by changing the paradigm to less pretty, less perfect, we have this huge gain of power. So that was one of my favorite questions on the interviews. Why do you think Kafka is so much better in performance? And the answer is because it's not JMS compliant. Another example is more from the infrastructure side. On this picture here, this is the traditional storage array for 24 disks, different hard drives, based on RAID storage array. That was and in a lot of use cases still is the default option for having the large storages. And RAID arrays have many benefits. You can have a lot of storage, you can have redundancy, you can have better performance than single drive, and in the same time it can behave just like one single drive for the computer that is using it. But RAID arrays are having one very serious problem. They require very expensive hardware. The array itself is very expensive because it's all digital signal processors, so it's dedicated built-in silicon just to run it. The drives are very expensive because RAID arrays assume that drives do not fail, or they fail, well, very rare. It can survive failure of single drive, but if two of them fail, that's a problem. The solution itself is so much fine-tuned that hard drives need to have the same rotation speeds of the disks, because otherwise the array won't be able to store the data on all the drives simultaneously. In the same time, there is a new generation of storage solutions. One of its called object storages, and one of its most famous solutions is Ceph. Ceph uses different paradigm. Instead of pretending we have one single hard drive and making everything within hardware, having all the array behaving just like one drive. Ceph doesn't pretend anything, and most important, Ceph is by default assuming that hard drives will be failing, and they will be failing heavily. Ceph assumes that in a storage during 1 year, 50 to 70% of hard drive will fail, and it's prepared for that. So, how the idea for Ceph started? You might recognize this picture. This is the Google first server room, and this is the second server room of Google. But this is how typical Ceph array looks like. Ceph takes a benefit of the fact that typical motherboard with processor is cheaper than dedicated signal processor for write arrays. So instead of buying a lot of dedicated hardware, you might just buy tons of generic motherboards with generic hard drives, bundle it up all together, install Ceph, and voila. Ceph is so powerful that Allegro is using it to store all the data of all the auctions, and in the same time, Onet is using Ceph to store everything, and I mean everything, not only not only the binaries, the emails, the content of the articles, videos for VOD. Everything is stored in Ceph, in single Ceph array, and solution for all the problems with hard drive space, performance, network performance with Ceph is the same. Just add several more nodes, and Ceph will take care of the other things. I don't know how many of you ever worked with AJB. It's not very popular right now, but a few years back it was, well, that was the debate that actually shaped Java in the way it looks like now. AJB was concept for distributed computing. It promised that you can write your code into isolated piece of code called bin and run it in dedicated application server that will take care of everything else, connecting bins together, take care of connecting to database, storing data. It even promised distributed transactions. The only problem with JB was it was so complicated it never really worked. There was constant problems with pretty much everything. The simple thing like changing messages between different bins, something that right now is handled with RESTful web services. AJB had a dedicated format. It was binary format of exchanging data, and it was so fragile that even changing minor Java version between two application servers usually was breaking the communication. In the same time, a different technology started called Spring. How many of you heard of Spring or using Spring? That's the reason it's more popular. Spring never promised to create distributed computing utility. Spring focused on providing useful features like implementing design patterns. Right now, design patterns are you could tell that design patterns was murdered by Spring because almost every useful design pattern is implemented in some Spring library, and the reason for Spring being successful was it didn't try to solve everything. It focused on just several most useful design patterns. It took the concept of beans out of AJB, implemented it in the most simple way, and it just worked. Not because it promised not because it promised to solve all your problems at once. It was because it was focused on solving the most important problems that you had at the time, and it was in the same time much more easy to understand because the concept behind Spring was much more simple.
Unless you need transactions, then you. If you need transactions, doing it in Spring was a pain in the back, and doing it in an application server was just.
That's true, but it's more of a problem of Hibernate, not Spring itself. And Spring, I think the difference is because I agree that it's tricky, but it's actually the same. It's tricky for the same reason with Hibernate as it was for Spring and AJB. So Hibernate is tricky because it promises too much. It promises to be abstraction layer, and it promises you to isolate you from the fact that underneath you have a database. That's the reason of problems with Hibernate.
But do you think that this is a solution, really? Because it looks like we can't bring you a good solution for distributed transactions, like transactions across multiple servers. So we resigned of this idea, and now it's your problem. Do your rollbacks.
Yeah, but
by your own.
But it actually works, right?
But I would like to have the framework which does this for me without having explicitly writing the logic for rollback transactions, for example, in such if you have several services.
Yeah, but okay. So if it was possible to write such software, then of course it would be better. But two-way commit is a problem that you cannot solve because you have the confirmation of a confirmation of a confirmation of a confirmation problem, right? It grows up to infinity. So if you cannot solve it because the logic, the mathematical logic behind the concept itself is not allowing you to have a solution, why pretend? It's better to be aware what's happening and use the tool for the job. You can use the proper architecture, like event sourcing. You might use different database storage, like NoSQL database. You might write your own logic in the services, being aware that at any step you might lose the synchronization. But it's a much better solution than pretending it will work and then waiting for the failure.
Okay.
And this is yet another historic example. I don't know if you ever heard about project Xanadu.
During the first meetup.
Yeah. Okay. Okay. That was
or seconds.
Yeah, that was in one of the previous meetups as well. Just because it's a great example. Xanadu was invented by Professor Ted Nelson. He actually invented hypertext. So before even it was possible to have an IT solution for something like hypertext, he invented the whole concept and he initiated project Xanadu in 1963 by publishing a book about what is hypertext and different types of hypertext. And when he started in 1963, he worked until 2014 on implementing good hypertext solutions. And in 2014, he released almost working, almost open source version. In the same time, in the span of 9 years, the simple hypertext invented in CERN took over the world. And we know we know that we're not using Xanadu, we're using HTTP. What is the reason? Well, Ted Nelson spent almost 50 years on solving the problem of losing the synchronization between different parts of the hypertext. What if the website that is referenced by your URL is not existing anymore or changes the location? He was trying to solve this kind of problems, and Xanadu has 17 different rules on how to solve the problem when your resource is not available, when HTTP has only one. If the resource is not available, display 404. One more comment. Why there was the era of perfect solution, why it lasted for so long? Well, it was because of the Moore's law. For decades, IT people heard that if your solution is not working well enough, if it's not performant enough, you just need to wait for 18 months and you will get you a computer that will run it. But there is a lot of problems that cannot be solved this way. Do you think Google or Facebook could wait for 5-10 years until better computers are available? And that is the reason why right now we are in an era of imperfect IT solutions. So it's about choosing the model that represents the reality, not fighting the reality, accepting the fact that some solutions are not possible and making it part of your design. So how can you use this knowledge in day-to-day work? One of the approaches is creating applications that use the concepts from Reactive Manifesto. Reactive Manifesto, one of the most important parts of the Reactive Manifesto is accepting that applications are failing and preparing for the failure when it happened, not if it happened. So one of the most extreme approaches for that is chaos monkey experimenting, switching off different parts of your infrastructure to see what happens. And one other option is to use this kind of checklist to recognize how much your system is how much your system is fragile for failure, but most importantly, what will happen if it fails. Because sometimes it's just enough to display error message. Sometimes it's just enough to make sure you're not losing any data. And by accepting the fact that your system might not be perfect, you can focus on delivering business value, which is the most important for every system owner. So the motto should be that imperfect is better than none. Thank you. Do you have any questions?
Yeah. Get back. So apparently you guys work in kind of a big enterprise and stuff. So how do you sell that? Like the imperfection?
Okay. It depends of the organization, but I think the
But
example.
in the bank, in a big bank.
In case of the bank,
The
it's
business
quite.
want to have results. They are not looking for the
In the
failure
bank-
costs.
In the bank, it's
Alright.
in the banks it's quite easy
Yeah.
actually, because banks are counting everything in the measures of money. So if you show your stakeholder that making better solution will take 2 years and will cost 5 extra millions, and in the same time, in case of the failure, you will lose $500,000 in
Just making the contingency in budget.
yeah. Then it's a simple decision.
But much it's changing. Banks start looking not only through the money value, of course they do. It's the most important. It's core business for them. But they also starting to see through the user experience, right? So
Well, it depends what
Yeah.
kind of KPIs the CIO has. Yes, but most of the time money is the key factor, and right now companies are beginning to understand one additional thing. If making better solution would take additional year, they have somewhere in mind that during that year, a company like Facebook might emerge out of some garage in California and just take their business.
Or such company could emerge and then bank will buy it.
Yes, that's the other solution, but with the insane price tags, it doesn't work. Like for example, Facebook tried to buy TikTok back, but they wasn't able to afford it. Right? Okay, thank you.